That was a part of that problem that I have on my updated thing. I've got to tell you how confident. I'm going off of 1A, where I'm 95% confident. Because that would change the z-score you want here, right? Obviously, if I want to be more confident, I'm going to require a larger sample for that, aren't I? Sure enough, if I make z bigger, isn't it going to make n bigger? That's the idea. So they've got to tell me how confident they want me to be, so I know what to plug here, so I can figure out what sample to be that confident. So now it's just purely plug and chug. So on one level, it's all about which formula do you use, and then plug the stuff in it. So this one, obviously I want to use one of the n formulas when they're asking me how large of a sample, how many things do you have to sample. That's a how many, that's an n. I don't know what n is. I got to figure it out. Steph. Yep.
Yeah, where'd you get a 70? That's what I'm asking.
It's all part of number one, right?
Yeah. Oh, we found it.
Height of men, and they tell me in the very first sentence that the population standard deviation is 2.5 inches. Yeah.
So you knew you kind of use one of the n formulas, but how did you know which one you had to use?
Because this was talking about to get to true mean height. Mean height. So not the percentage one. It must be the one that's dealing with means, and that's the one that's a standard deviation in it. Mean and the standard deviation, they go together. This guy. So this one would be, if they're talking about the true percentage of people who smoke, that would be this one. This is the true mean of the blah, 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 blah. That would be this guy. So this one's asking about how big of a sample do I have to take to be within 0.5 inches of the true mean height. So I know it's got to be this guy.
Yeah, that one was true percentage.
And if it said true percentage, I'd have to use that one. Yeah. So let's see what I got. 1.96 squared, 2.5 squared, 0.5 squared. And I just throw it all in there and see what happens. What do you guys get? 96.04? And you always round up. Because you need at least 96.04 men. I can't find 0.04 men. If I make it 96, it's too small. It's got to be at least this, so you always round up to the next number, 97. I can get a hold of 97 people, that's easy. If I go to 96, is that big enough? No, because this tells me n has to be at least this to be within that. So if I make it 96 men, I'm not within this anymore, am I? And it's a small point, but still, you just always take that up to the next number. Okay.
97.
Yeah.
The answer is 97.
Yeah, so what does that mean? If I took a sample at 97 men, what would my error be? 0.5 inches. Real quick, let's try it. Let's try it. So we're done with this problem, right? 97 men. That's how many men I've got to talk to, right? Total. And actually, look at 1A. I've already talked to 22 men, haven't I? So I really just need 75 more. But my claim is, what this is supposed to mean is, if I do take this big of a sample, my error better be 0.5 inches. So let's look at what our error will be. And then some of you guys might realize, this is kind of silly math. Of course it's going to come out right, because I forced it to come out right. But if I put in there for the error is z sigma over square root of n, right? So it's 1.96, sigma is 2.5, over the square root of 97. That better be 0.5 inches or else I'm full of crap. Let's see, 1.96. I always get a little concerned when I say something like that. 0.4975, blah, 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 which I'm sure is 0.5 inches. Right? If my boss said you got to be within 0.5 inches, anything less than that is fine. Why is it less than 0.5? Because we made 97 bigger than what it should be, 96.04. But I can't get 0.04 dudes, thank God. That's freaky. So there you go. When I make it 97, the error is 0.5, exactly what we said it should be, right? So if I took a sample of 97 men, the error is guaranteed to be at most half an inch. Okay. I don't know if you guys really see that. So if I'm trying to design a door height for something and want to know within half an inch before these people make this wall and put the door frame in, I better get enough people so that I'm sure within half an inch. If I don't want only so many people ducking to get under the door. Okay. The biggest problem, I think, with this section would be which formula to use when. And that's already the question I've gotten, which is totally understandable. But it's going to have to be incredibly obvious, because at some point they have to say, make a confidence interval for a percentage. Okay, I've got to use the confidence interval that's got the p hat and the q hat in it, right? Or the mean, okay, it's going to be very obvious. Find how large of a sample they have to take to be within 2% of the true percentage. Oh, it's got to be the n equals z squared p hat q, the one with the percentages in them, right? Of course it must be. If it's not percentages, it must be the other one. Cool. And you can have all 4 of those sitting on your formula sheet, ready to go. Okay, you guys don't look any happier about that. Okay. I'm not sure what else to do for you. What about number 2 here? Sounded familiar. I thought we had done it. Because p hat, I get p hat.
We did clear it. We did 42.
What do you get there?
0.704.
704. So what's q hat?
1 minus 0.704 equals 0.296.
296. Okay. And the z score for 99%?
2.575.
Cool. Right? Don't worry, you're not become a geek if you start remembering these numbers. You're going to see the same numbers every now and again. So they're going to become second nature, hopefully. Now it's just a plug and chug. I've identified which formula I need. I've identified the parts of the formula that it needs. Now I just plug it in and chug away, right? So now I get p hat, so 0.704, give or take this many, 2.575 standard deviations. What was it? Thank you. So you can figure out the error. Every confidence interval problem sort of has the same tone to it, the same beat to it. Get this, plug it in, chug it out, bam, It's always the same. Find the error. So what do you guys do? Let's see. What do you guys get? Front row. 0.46. Okay. Which again is like 4%, almost 5%, right? It's 4.6%. So that makes sense to me. I expect, at least around 2%, at most around 7, 8%. Most of the time it's 3 or 4%. Just a consequence of the formula and the numbers that normally go in them. So now you just subtract it. So you get 6, what is it, 5, 8?
Yeah.
Oh, that's what you're saying. I'm with you now. 2.75. So we are 99% confident that the interval 65.8% to 75% contains the true percent, what was this one all about? Of registered voters who voted. Now, we look at, now that's done, right? I've made the confidence interval. That part of it is done. There's the confidence interval. Bam. It was based on what people told me. Some of you guys might remember a problem from earlier about people washing their hands. There was one where they asked them if they did, and there was another one where they observed if they did, and it was very different. Voting is another big thing with that. Did you vote? They will say yes, even though they didn't, because they don't want to be seen as not doing their civic duty, right? So if I know that actually 42% voted by looking at the records, I know that 40% of the registered voters voted, what is most likely true about some of the people I talked to? They more than likely lied. Exactly. Right? What's the probability that I'm wrong? It's roughly 1% in a way. It's really actually 0.5%, but we'll say it's a 1% chance I'm wrong. So what happened? What's most likely? Is it most likely that I'm wrong or more likely that they lied? I think they lied. Because it's more likely that somebody lied to me. Okay. Yes, ma'am.
What time is, sorry to interrupt, but what time is your tutoring tomorrow and Wednesday?
Oh, I have no idea at the moment. I sent an email out earlier. I've got my schedule on my computer. Yeah.
Can I just email you?
Sure. Let's see. Tomorrow's Tuesday, so Tuesdays and Thursdays, 9 to 10:30. I can't remember where I'm going to start in the Mass Study Center.
Wednesday,
Yeah.
12:30 or Wednesday?
Yes, Wednesday, 12:30 to 1:30. Cool. All right. Now, all right, guys, so there's been a major assumption we've been making, and that the problems have been making, that normally isn't true. So, remember where this whole thing came from. This whole thing came from this formula here. Remember this? This whole thing came from that thing. Remember that? Where I said, do we normally know the mean? No. So we have to use x bar to estimate it, right? Then I say that I think I'm wrong by this much. Now, there's a big part of that formula that stayed the same that really normally shouldn't. If I normally don't know the population mean, I probably also don't know the population standard deviation, right? Why would I know the population standard deviation and I don't know the mean? That doesn't make any damn sense. Now, it doesn't invalidate everything we've done. Everything we've done is valid if you know the population standard deviation. If you don't, there's something slightly different you have to do. And I'm always curious if you guys are worried that I'm not being technical enough. I think most of the time you think I'm being too technical, so I should stop worrying about that. But really, the real thing here is the z-score, I use it if I know the population standard deviation. If I don't know the real standard deviation of the population, what do you think should happen to my confidence interval? So, for example, let's say I make a confidence interval, and I say it's somewhere in there, right? And this is based on me thinking that I knew this. So I think I know, I think I know this, right? So then I made this confidence interval. What should happen if I go, oh shit, that isn't real, I don't know that. I have to use the sample standard deviation. What do you think should happen to this? Should it get bigger or smaller to cover for that fact that I know less? Okay. Got about half a yes going one way or the other. Think about what this means. I get a sample percentage or a sample mean, right? In this case, it was a percentage from earlier. And I go out so much because I know that I'm probably wrong. I know that it's got to be close to it, but I'm going to say it's somewhere in between 72 and 78%. If I go back and I go, oh shit, part of the equation I used isn't really the population standard deviation. It's actually a sample standard deviation, which is more than likely